Hey everybody, welcome to Lesson 4B, Quadratic Relations, Chapter 4.2 in the textbook. Alright, so let's start off the top. Recall, create a table of values for y equals 3 over 2x plus 5, then provide a quick sketch. By now, you should look at that and realize that is a linear equation. Okay? It is a linear equation. You must be sick of it by now. That was the first part of grade 10 and most of grade 9. Let's create a table of values for this linear equation. Okay. X, Y. Okay, I'm going to choose random values for the X, 0, 1, 2, 3. And I'm going to substitute these into our linear equation to find the corresponding Y value. Sub in 0, 0 times 3 over 2, which is 1.5. 1.5 times 0 is 0, plus 5 is 5. Okay. And then if I substitute 1 for X, that gives me 1.5 plus 5, that gives me 6.5. And again, if I substitute 2 into here, I would get 8. And if I substitute 3 into here, I would get 9.5. Okay. And I promise my writing will get better as I get more practice using this thing. Okay, now, here is a table of values for this corresponding equation. If I wanted to provide a quick sketch, I know my y-intercept is at 5, and my slope tells me it's going up 3 over 2, up 3 over 2, and my line looks, oh, that looks horrible. Let's pretend that's a 5. Okay, that is a 5. Up 3 over 2, up 3 over 2, yada yada. Now, going back to the table of values. If I look at the differences between the the y values, let's see what we get. So from 5 to 6.5, 6.5 minus 5 is 1.5. 8 minus 6.5 is 1.5. 9.5 minus 8 is 1.5. Now, what do we notice about the first differences? Ignore the word first for a second. Let's look at the differences. The differences are the same. They are the same. Okay, they are the same. Now, they're called first differences. You'll see why they're called first differences in a few moments. But for now, just realize they are the same. It's also no coincidence that they are going up by 1.5, which is the slope, 1.5. Okay? That should make intuitive sense. Now let's scroll down and look at the second equation. Now we're going to create a table of value for this quadratic equation. Forget the word quadratic. I will go into more detail later on. But let's just create a table of value for this equation. Now, right off the hop, I know that this won't be a linear equation. And a quick way to tell that that won't be a linear equation is the fact that if you look at the exponents of the variables, you see that for a linear equation, the exponents is simply 1. But where's the 1, you ask? Well, because you don't see a number up here, we assume that it's a 1. Now let's look at this. I notice that the exponent for my x here is a 2, a square, which should tell me right off the bat that it's not going to be a linear equation. But don't take my word for it. Let's check it out. So create a table of values for this, and I'm going to use 0, 1, 2, 3, 4. By substituting in these values, so 0 for x, so 0 squared is 0, minus 2 times 0 is 0, 0 minus 3, my y value would be negative 3. Excuse me. If I sub in 1, 1 squared is 1, 1 minus 2 times 1 is negative 1, negative 1 minus 3 is negative 4. And again, you can plug all this in your calculator. I don't expect you to do the mental math. 2 squared is 4, 4 minus 4, because 2 times 2 is 4, 4 minus 4 is 0, 0 minus 3 is negative 3. I'll do the same thing here, 3 squared is 9, 9 minus 6 is 3, 3 minus 3 is 0. Last but not least, 4 squared is 16, 16 minus 2 times 4, so 16 minus 8 is 8, 8 minus 3 is 5. Okay. Now, we noticed from up above that the first differences are the same tells us that it's going to be a linear function. Okay. Now, let's take a look at this, and I'm sure some of you could guess that the first differences are not going to be the same. But let's check anyway. Okay, so in this case I have negative 3 minus negative 4, negative 3 minus negative 4, which is the same thing as saying negative 3 plus 4, give me 1. Now let's check the next one. Negative 4 minus negative 3, which would be negative 4 plus 3, which would give us negative 1. And then here we have negative 3 minus 0, which should give me negative 3. And then last but not least, 0 minus 5 will give me negative 5. Looking at that, are the first differences the same? No. Let's check the second differences. Okay, so I do follow the exact same steps. So I'm going to have 1 minus negative 1. What does that give me? 2. Negative 1 minus negative 3. 2. And then negative 3 minus negative 5, also 2. Are the second differences the same? Why are they called the second differences? Simply because we're taking the differences of the y values the second time. Okay. So what do you notice about the second differences? They are the same. Okay. Now, if I were to take this and graph this in Desmos, which I would recommend you try right now, okay, take out your phone, type this into Desmos, you would get a graph that looks like this. Y equals x squared minus 2x minus 3. Y equals x squared minus 2x minus 3. Now, based on the table of values, we know that the second differences are 2, the 2 isn't significant, it's the fact that they are the same. So then that tells us that it's going to be a quadratic function. Now, a quadratic function is of the second degree. Okay, so if you see an x squared anywhere in your function, chances are it's going to be a quadratic function. Now, some of you who have been watching the Khan Academy videos notice that Khan may have used these words interchangeably. Okay. A parabola is the shape. It describes the shape of the quadratic function. Okay. The shape. Now let's scroll back up here. Okay. Now here is the quadratic function / equation. Now let's look at some of its key features. Number 1. Let's go down. Okay, so let's look at the vertex. So this is called the vertex, and is usually the highest or lowest point of a parabola. Okay, so highest or lowest point of a parabola. Okay. Now let's take a look at these 2 points. Now they both cross the x-axis, and we've seen this before. These are what we call the x-intercepts, simply because they cross our parabola, crosses our x-axis at those 2 points. Hence, they're the x-intercepts. Okay, now remember, x-intercepts are coordinates, they're points. Okay, so in this case, one of the x-intercepts is 3, 0. Remember, x always goes before the y. The other x-intercept over here would be -1, 0. Okay. And last but not least, what color have I not used? So let's go. It doesn't matter, I'm wasting too much time on this. I'm just going to use black. Okay. Here, it crosses the y-axis. Let's call this our y-intercepts. Okay, whoops. Now, y-intercept, the y value is always the second point in a coordinate. Okay, so 0, -3. Perfect. Y-intercept. Y-intercept. Okay. Now, if I look at this parabola, I will notice that all parabolas are perfectly symmetric. Okay, so if I drew a line down the middle, this will cut my parabola exactly in half. Okay. Now this line that I drew, okay, this is what we call let me just draw an arrow, axis of symmetry. Okay. So in this case, if I were to ask you, what is the equation of the axis of symmetry of this particular parabola, you would tell me it's this vertical line. Now thinking back to our first 3 chapters, how do we write the equation of a vertical line? Well, in this case, because it's a vertical line, it has an undefined slope, so the equation is simply x equals to 1. Okay, axis of symmetry. Now you can see that down this line, it cuts our parabola exactly in half, and that's why I included those green coordinates there, so you can see the perfect reflection. Okay. Moving on. Now, oh, right. Notice how I put the word standard form here. Okay. Now, if I just think back to lines again for a quick second, the form we're used to seeing in lines when we write equations of lines, is y equals mx plus b. Okay. Now, does that mean equations of lines were always written like that? No. The only reason it was written like that is so we can quickly and explicitly and directly determine what the slope is and the y-intercept. With those two features, I'm able to quickly graph the equation of a line. Now, same idea for a quadratic function. But instead of simply having one form or even two forms, because we know with lines, they can also sometimes be written in standard form. Okay, in which case you would have to rearrange or convert to slope-intercept form in order to explicitly find the slope and y-intercept. So just like the lines, with quadratic functions, let me just scroll down, we are usually given the equation of a quadratic function in one of the 3 forms, standard, factored, or vertex. Now, we will be diving into each one of those forms more in depth later on, but for now, what I want you to do on your own time is create a table of value for both of these forms. Okay? And again, use the values 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Using those x values, find the corresponding y values. Okay? And you should see that those y values would also end up being the exact same y values that you got back here. Okay? And in fact, if you were to graph this in Desmos, which is what we call the standard form, graph this in Desmos, which is what we call the factored form, and graph this in Desmos, which is what we call the vertex form, you will realize that all 3 of these graphs are, all these equations give you the exact same graph. Okay. Now, for the 3 forms, what did you notice about the information that each form directly gives you? Okay. Now, this was obviously designed for an in-class lesson, so I was supposed to give you some time to plot the different values for the table of values and realize that all 3 graphs are the same. But and with those three forms, I wanted you to make the connection that each one of those forms gives you a different piece of our graph. Okay? But of course, this is a quick online lesson, and I'm fairly new to this, so I am no Mr. Khan just yet. But if I just backtrack, and now this is the standard form, here is the equation. Can you see anything in this equation that is directly visible on this graph? Correct. The standard form will give us our y-intercept. Okay. Now let's scroll down. So what do you notice about the information that each directly provides? Well, standard form, you can say it provides the y-intercept. How about the factored form? Okay. Well, looking at these two values, so keep in mind a 1 and a 3. Now, ignore the signs for a second. Just look for the 1 and 3. Do you see that anywhere? Correct. The x-intercepts 1 and 3. Now, I will go into more detail as to why this says x plus 1 and my x-intercept is negative 1, and why this says x minus 3, but my x-intercept here is a 3. I will go into more detail later on, but for now, just wanted you to realize that our factored form gives us the x-intercepts. Okay. And last but not least, vertex form. The name itself kind of gives it away. What did we say the vertex was again? Let's scroll back. The highest or lowest point of a parabola. Well, in this case, what is our vertex? Well, our vertex here is 1, negative 4. So the vertex was 1, negative 4. Let's scroll down. Here's the vertex form. Oops. 1, negative 4. The vertex form gives us the vertex. Okay. Now, as you can see, each form gives us a piece of information that we can use to graph the function. In order for it to be useful, however, we need to be able to convert between the three forms. So everything we'll be learning in these 3 chapters will be aimed to achieve just that. Okay? Now, so what I want you to do is complete the sheet. Now, most of it's already completed. You just got to copy what I had written down and maybe complete this part right here. And you're going to upload it. Okay. Now, once you've uploaded, complete these questions from your textbook. Okay. Now, if you don't have a physical copy of the textbook, you know where to find the non-physical copy of the textbook. Okay. And then complete these questions now, and then upload these together. Okay. And yeah, any questions? Join the tutorial or comment on the feed, the forum.